Okay, for 6.4, we're gonna go. We're still in 6.4. We're gonna talk about some of the other things. Next time, we're just talking about sign properties. So let's first go back to like the quadrants, the Cartesian plane, and label each of my quadrants. So when I run my angle around through here, the point I'm going to is A, B. So if we think about that point A, B, we think about sine of x is B and cosine of x is A. Okay? So that's using the unit circle like we did in the last section. So up here in the first quadrant, they're both positive. So that means sine and cosine are positive. In this next quadrant, A is negative but B is positive. Down here, A is negative, B is negative. And down here, A is positive, B is negative. So what does that tell me? That says that sine and cosine are positive in the first quadrant, and by extension, tangent is going to be positive. In the second quadrant, it tells me that sine's positive, cosine's negative, and so by extension, tangent's negative. In the third quadrant, it says that sine's negative, cosine's negative, but whenever you divide them for tangent, tangent's positive. And then in the fourth quadrant, we have that sine's negative, but cosine's positive, and then that makes that tangent's negative. So right here, I have only written down where these values are going to be positive. Otherwise, they're going to be negative. Okay? A way that I remember this is I think about it in counterclockwise manner. I think A, S, T, C. A, S, T, C. So different people make acronyms. You can make whatever acronym you want. A, S, T, C in that order. That means that all are positive, sine is positive, tangent's positive, and cosine is positive. Okay? Now, what does that give us? Well, we can use something called reference angles. What reference angles are is we're given a value, say we're given sine of theta equals 4/7. We're not given theta, we're actually just given what it equals. And say cosine of theta is less than 0, so it's negative. So the only place where sine is positive and cosine is negative is in the second quadrant. So we're over here. Okay? So this is theta. But you can really kind of just use this angle here and make this a right triangle. So then, if you think about this being your angle instead of theta being all the way around over, sine, we know sine is opposite over hypotenuse. So this would make this 4, make this 7. So then if we use the Pythagorean theorem, a squared plus b squared equals c squared. That's going to be 4 squared plus b squared equals 7 squared, which means that b is the square root of 7 squared minus 4 squared, which is 49, minus 16, which b is the square root of 33. Okay, so this is saying that this is the square root of 33, but you see that we're moving in that direction. That makes that negative because it's going to the left. So that's your adjacent side. So if you want to find all the other trig functions, we already have sine, cosine, of theta is adjacent over hypotenuse. Tangent is opposite over adjacent. That's 4 over the negative square root of 33. Then cosecant is flipping sine, so that's just 7/4. Secant is flipping cosine, so that's -7 over the square root of 33. And then cotangent is flipping tangent, which is -square root of 33 over 4. That's how we use reference angles. Okay? Now, next thing we're going to talk about has to do kind of with graphing, and that's periodic functions. Now, if you have a theta running through here, okay, if I go ahead and run that thing around, okay, and it's coming to AB, right? So that means sine of theta is B, cosine of theta is A. If I run this sucker around again and it's back in the exact same position, A and B is still in the same position. But one rotation all the way around the circle is 2 pi. So whatever angle we're at, theta is now going to be theta plus 2 pi. So now sine of theta plus 2 pi is still the same thing. Cosine of theta plus 2 pi is still the same thing. And that's going to be true for every case. So if you keep running it around, every time you go around it gets in that same position, it's going to be the same. So this is called periodic functions. Every value of k that we run this circle, basically this terminal side around the circle, it's going to end up in the same position, and so it's going to end up always being, let me write this where you can see it, sine of theta plus 2k pi is equal to sine of theta, whatever that theta is, always. Cosine of theta plus 2k pi is equal to cosine of theta. Just going back to the thing. Every time it rotates around the circle and gets in the same position, you're going to get the same thing. So, if you look at, say, a graph, let's say this is the graph for sine. Okay, sine starts out at 0, and it maxes out at 1 and comes down to -1 at pi over 2, and this one's at pi, and this is at 3 pi over 2, and then when we come all the way back around the circle, we're at 2 pi. It repeats itself over and over again, so it's just going to do that again. So then now this would be, well, this would be 3 pi over 2, excuse me, that's just 3 pi. And 4 pi. And it just keeps repeating. Cosine starts out at 1 and goes down and ends at its same self. So then this would be 2 pi, it would be at -1 at pi, and so on and so forth. This would be pi over 2, and this would be 3 pi over 2. And then it would repeat the same thing. So this would be 3 pi, no, this would be 3 pi, and this would be 4 pi. Okay? Periodic, that's the idea. It just keeps repeating itself. Okay? Now, tangent's a little different. Remember, tangent is sine over cosine. Okay, if you remember that, then when you go to graph it, you can actually put this in your calculator and see at sine, at pi over, sine of pi over 2 and cosine of pi over 2 was 1 over 0, which is undefined. So So every value of pi over 2 is going to mess up with tangent. So it actually ends up looking like this. Every pi over 2 is a vertical asymptote. So this one is negative pi over 2. This is pi over 2. This is pi. This is 3 pi over 2. This is 2 pi, and it just keeps repeating and repeating and repeating. Oh, sorry. No, that's wrong. Let me take this out. Yeah, this was pi over 2. This was 3 pi over 2. And this one right here was 5 pi over 2. So it crosses at 0, pi, and 2 pi. And it keeps repeating, Because at pi and 2 pi, it's 0 over 1, which is just 0. Okay? So it has a lot of asymptotes. So basically, you can't take tangent of any like 90 degree, 270 degree, anything on that vertical axis there. Okay?